Hello everybody, welcome to this session today. Today I'm going to demonstrate how to set up PredictionIO on Heroku. The purpose is to gain some understanding of PredictionIO. We'll be doing this hands-on, so compared to other sessions you may have seen, I'm going to actually show you through the command prompt how to do it. The purpose really is to gain some understanding of it. The tools we're using is the PredictionIO framework, Heroku, and the steps roughly would be deploy the event server engine from GitHub, deploy it to Heroku, upload some test data, train it, and ask for predictions. Okay, so first let's go to the Apache website and we're going to take a look at what PredictionIO is. It is basically a company that Salesforce had acquired back in 2016, but then they donated to the Apache Foundation, so it can be open source. And if you look at the architecture, it sits in the cloud, it can be deployed anywhere, Heroku, Amazon, anything you want, or even account locally. And there's the concept of the event server and the engine. The event server is actually more like a data store where it stores a bunch of events that's being streamed in or copied in, and the engine is actually what computes the algorithm as well as provides the prediction. Okay, so we're going to take a look at this website that's called SFVC Workshop that I found Googling it. I think this is one of the sessions that somebody ran and got followed to the letter to see what we can do. So the first thing actually we'll be doing is cloning the GitHub repos, apps from Heroku Online. Spare it to me. Okay, so now we're going to be cloning these two repos. Okay, so the next step is we'll just go into each of the directories and then create a Heroku app from it. And then you can do a bunch of things like checking to see if the Git remote's been set up and stuff, but probably not much of a point for us. So let's go into the event server directory and then create the app. So I'm going to use instead of -1 because the name needs to be unique within the Heroku space. I'm going to do a -py, which is my initials. Okay, so we've cloned the repo, and I think we're going to bypass that. And then next would be pushing it to the master. So git push Heroku master. What's nice about Heroku is that it can detect when you're uploading. So since it's a scale app, and then it's installing a bunch of things like a JDK 1.8, so it takes care of a lot of the dependencies for you, so you don't need to worry about it. I mean, it'll be similar to Docker, except for with Docker you'll be setting it yourself, and with Heroku you can just kind of clone the repo and then upload it to the server. Okay, so the instructions kind of say once that's done, we can be setting up and recording the database URL. So it's going to be a Postgres database, and we'll just be storing that. So what I'm going to do is I have a text edits notepad app open, and I'll paste a bunch of stuff in. Okay, I just paused the video, and then once the song was done. Okay, it is done. Let me just readjust the screen a little bit so then have the windows side by side so you can see it. So it'll be setting up which the database connection is for the engine. So we can see is that Heroku is provisioned Postgres server. It's actually on Amazon. So I'll paste it into my text edit to be used later on.
So for those people who are not that's comfortable using the command line, we can also take a look at it at Heroku Online. As you can see, it has been provisioned. You can click into it and do a whole bunch of stuff. It's really basically a full-scale instance of Postgres, and you can see like we actually had very little to do with setting it up. It was just became available. Okay, so next we'll be creating the Heroku app. I'm not gonna call it My App One. Let's call it Recommend App. Makes it a little bit more intuitive. There's actually no reason it needs to be called that. Uh, it's just that within PredictionIO, each app encompasses an algorithm. Okay, so let's just create a new console app and call it Recommend App. So now it's creating it. Okay, so you can see that now it's provided as got the configure variables, one of which is the access key. So we are going to be copying that and saving it in the text edit. We'll be using this for later. Okay, so reading ahead, basically we're going to be storing this into an environment variable, access key, to be used within the scripts that we'll be running. This saves you from typing the very long convoluted access key later on. So within Linux or Mac, you just need to export it. Next step would be to populate the event server with events, and this website provides 3 loops. It doesn't provide a lot of annotation about what it does, so I'm going to kind of describe it a little bit more. So the first loop is actually for the user creation, second one's for item, and third one is for the user to item association. So the user can see it's actually a loop that goes from 1 to 5, so it will be creating 5 users. You can see it's referencing the event, or which of the type user really. Next one's items. It loops from 1 to 50, so you can be creating 50 items. Lastly is the user to item association. It's still an event, but the entity type is user and associates it to the target entity type, which is item. So we'll be digging further into this later on, but that's what the algorithm uses. Okay, so we just kind of paste each one of these into our command window, and then this one takes a bit longer to use to run because it's 50 items. It's actually curl command one by one, so definitely not the most efficient, but still pretty fast, so I don't mind. Okay, so let's take a look at the server. It basically dumps all the events that we've loaded in. And one of the more important things is we want to kind of see this in a format that's easy to view. So just go online, search for any JSON viewer and beautifier. Let's choose this particular one because it seems to me it has the fewest number of ads. Okay, so what you can see now is you can tell that these are the events, and um, entity type is user, and then like user 1, user 2, user 3 to 5. And the next set of records would be for the item. So item 1, item 2, and then datasets puts them into category C2 and C3, and so forth. Yeah, so next important part is actually the limit command at the very end. By default, it actually just shows a truncated list of events, and then that's why it was a little bit confusing. So by appending it with ampersand limit equals, let's say, 200, then it shows you a lot more of these events. So recall that we had, let's see, there's 5 users, 50 items, and 5 relationships, so that's 60. But so anything that's bigger than the default. Okay, so now the next step is to deploy and then set up the engine. So I'm going to the engine directory. Heroku creates the app, and then again I'm change it from -1 to -py. So it needs uniqueness in the namespace. Let's create that, and then I'll be pushing it to the master. So push Heroku master. Okay, I just put the video on pause just because that took like at least a few minutes. Let's not waste Harry's time. Okay, so now we're going to look at the add-ons, and so as you can see, Amatic provisioned the Postgres database. So what I'm going to do is remove it. So per the instructions, it says remove, but then it does say it's deprecated. So we'll be using the destroy action instead. Destroy the database, and per the usual procedure, to make sure that you really mean it, you need to type in the name of the resource. Okay, next thing to do is to set the database URL, because remember, our engine doesn't really know where the event server is. So I copied it from the text edits that I had before. Paste that in. So there's a bunch of other configuration parameters that we need to put in. So this is more or less just cut and pasting. Important to replace your access key and the name of your app. So I didn't call it my app one. I'm gonna call it recommend app. We'll paste that in. And then the terminal replays the configuration parameters I put in. Okay, I put the video on pause, now that we're back. So I'm going to set the Java options to have it run using 512 megs of RAM. And then the tutorial actually recommends that we scale down the web dyno, set web to equal to 0. For the free tier, maybe makes a difference if you're running a paid version, maybe not, but nevertheless it's good to save some CPU cycles. And next thing to do is run the Heroku train command. Okay, so here it goes. It takes a while to train, so I'll put the video on pause. Okay, so now we're back, and last step is actually to test it and ask it to predict. So you paste this curl command in, just replace the app name. So what's actually doing is it's asking for item I3. And I got tripped up about this on this a little bit because the dataset is actually random. So if you look at that line above, the user item, it's random. So with the dataset I generate, there's actually not any item I3. So that's why item scores, the structure returns nothing. So let's do a search for item 3. Okay, so you can see this first one there, it's got the categories, it's an item by itself. Item by itself. And it's not actually associated to any user. So because it's not associated to any user, then it's not being recommended, you could say. Okay, so now what we actually do is go back to our input data and try to find out which items actually have an associated user, because that's the item that we want to use within our test. Okay, so at the very bottom, these are the items that have been generated. So I, 12, 20, 19, 15, and 46. So let's go back to our curl command and Sorry, it's need to clear my terminal. So item 46. So there you go. So for item 46, the prediction or recommendation is also item 20. So go back to the input data set and see like so we have like 46 and we also have 20. I seem to understand a little bit more about how the algorithm works, because right now, I mean, user 2 is associated item 20, user 5 is item associated item 46, but then there isn't actually a single user that's item that's associated both. Okay, so just a quick recap. This is what we have done. We've set up PredictionIO, put it on Heroku because that seems to be the fastest way of running it. We could have done it in some kind of other virtual environment as well. And then the steps we did was we pulled down the event server, ended with GitHub, and we uploaded it. Okay, thanks for watching.